today is to figure out how can you find the exact length of a line segment. So we're going to pick out 3 steps that are going to help us find the exact length of a line segment. And right here, we have our line segment. And so we're going to figure out exactly how long that is. What we do know is that it's longer than 2 because it's along a diagonal. So 2's going to be too short for this. So in your notebook, on section 2.3, it says you can use a square to find the length of a segment connecting dots on a grid. For example, to find the length of the segment on the left, draw a square with the segment as a side. The square has an area of 5 square units, so the segment has an exact length of the square root of 5 units. So going back to our picture, oops, there we go. Going back to our picture, what is the first step that we are going to take in order to figure out the exact length of that line segment? And I heard a lot of you had really good conversations with your group. So what are we going to do first? Colby?
So you're going to do, because you have, so you're going to have to do the inverse operation, right?
The inverse opposite.
Inverse opposite of the line that you have. So that would be 1.
So tell us what you're doing. Why are you doing that?
Because this is going to make a square.
Okay, so for number 1, I'm going to say make a square. Make a square using the line segment. And your sheet should look just like mine. It's on note paper, that's your cue. Okay, so
If you had a different way, does it have to look exactly like it, or should we just do it again?
I would love for you to write down what I have here, and then you're going to get to do some example problems. This is just your reference to go back. So I would love for your notes to look just like mine today. Thank you for asking. Okay, I interrupted you. Keep going.
So you do the inverse opposite, so then it would, if the line is 1/2,
Okay.
it would be -2/1.
All right, so we have the slope here, right? And the slope is going to be the change in y over the change in x. Notice that for here, this goes up 1 in the positive direction, so y is a +1 change, and x is a +2 change. So your slope is going to be 1/2. Okay, keep going. And then you said we have to figure out another side?
Yeah, so you have to figure out another side, like I did here the vertical side. So that would be -2/1.
Yeah, so he found the inverse opposite, which is going to be the slope of the perpendicular line. So the perpendicular line is going to be -2. So I'm going to take where I started, I'm going to go down 2 over 1. So my next point will be here. Now my next line needs to be parallel to my top line. So what is the slope going to be of my next line? I'm going to start going this way. What's the slope of that line going to be if it's parallel to the top line? What's it going to be, Landon?
1/2.
It's going to be 1/2 because it's the exact same slope. Okay. So I can think of that as going down 1, -2, or from this one it's up 1, +2. And so there's my square. Okay. So we went ahead and we drew a square. What is the next thing that I'm going to do, Spencer?
You're going to find the area of the square.
Let's find the area of the square. Now there are 2 ways that you may choose to do this. One way that you might choose to do this is to draw a larger square around your smaller one. The total area of our larger square is going to be found by the number of square units inside of it. Now remember, you're not counting the dots, but you're counting the spaces. So this one ends up being 3 by 3. So my total area of this is 9 units squared. That's my total area.
Is that the next step?
This is the next step. I should write that down. So we need to find the area of the square. Now I want to take off each of those little triangles on each of the corners. Katie, what is the formula for the area of a triangle? You're so close.
Oh,
Divided by 2. So what would be the area of this triangle right here? 1, yeah. And how about this one right here? And how about this one right here? They're all 1. Okay? So from our 9 units squared, we're going to subtract 4. We're just going to subtract each of those triangles on the side. So we have 9, which was the total area, minus 4, which is the area of each of the triangles, which is going to give us 5 units squared. So our total area of that, of just the square we're looking at, is going to be 5 units squared. Now that's not the only way to figure out area. You might also do something like this. Okay. So you could also do and find all the triangles inside. And some of you are really, really good at this. Okay. And then here we can see 1, 2, 3, 4, 5. And so that way we could also say 5 units squared. It's really whatever you're most comfortable with, but kids tend to be more accurate using the first strategy. Okay, let's go back. What is the last thing that we are going to do in order to solve this? We have one more step. Eli?
Find the square root of the area,
And that is?
side length of the square.
Yeah. So we'll cross that off there. All right. So the side length is the square root of the area. The side length is the square root of the area. So in this case, I can just look, if I know that this total area is 5 units squared, the side length right here is going to be the square root of 5. If the total area is 17, the side length is going to be the square root of 17. If the total area is 16, the side length is going to be
4.
Oh, you guys are good. I was going to try and get you, but you're good. Okay, one more thing. We can check this. Please write this down. Because we know, and you guys worked really hard on all of these rules about radicals over the last 2 days during your stations. Because we know if we think about finding the length times the width, which in this case is the square root of 5 times the square root of 5. That is equivalent to the square root, and that's just the two sides of our square. That's equivalent to the square root of 5 times 5, which is equal to the square root of 25, which is equal to what, ladies and gentlemen? 5, which is our area. So if we think about 5, the square root of 5 times the square root of 5 will give us our total area of 5. So that's just one way we can think about checking that. All right, so all of that needs to be in your notes today.